Hi everyone, this is Tiffany. Welcome back to CSE 545 Software Security. In this video, I will talk about use after free vulnerabilities. Use after free is a class of vulnerabilities that allow attackers to arbitrarily read, write, or even control the control flow of a program. Since we have talked about Heap and we talked about Tcache in Heap, in this video, we will focus on use after free vulnerabilities that are related to Tcache. Note that use after free is not only for Tcache. In the future, when we talk about other heap data structure, I will come back to the use after free vulnerabilities again and give you a broader notation for the concept of this class of vulnerability. Right now, let's start with use after free vulnerabilities for Tcache. Recall that in the last video, we learned about Tcache data structure in heap. Tcache is composed of two parts, counts and entries. Each Tcache entry is also called a Tcache bin. In Tcache, chunks with the same size will be stored together in one Tcache bin. And those chunks are stored as a list. In this list, the head of it will be stored in Tcache entry, which is Tcache bin. Each chunk also stores the information of the next chunk. For example, in this screenshot, the chunk of 603280 stores the information of the next chunk, which is 603260. So if you look at the Tcache and if you look at the heap layout, you'll be able to find that hex 603280 points to the next one, which is 603260. In this way, all the chunks are connected together, linked from one to the next, and again, the head of the chunk list will be stored into Tcache bin. Use after free vulnerability is a class of vulnerabilities that allow attacker to use the freed chunk. Attackers can still access the freed chunk even though the chunk is freed. In this way, the attacker will be able to add the information inside a freed chunk, which can be the metadata that is stored in the freed chunk. Attacker will be able to change the next chunk by overwriting the metadata storing in the freed chunk. So if there is a victim location, say it's a function pointer, or it is a special memory that contains sensitive information, then attacker can use of the free vulnerability, change the information of the metadata so that a free chunk will be point to another victim place. After that, if attackers can also control the execution by call malloc by twice, and also the malloc contains the same size of the chunk, then the first chunk will be used for the first malloc, and then the second, which is the victim count, will be used for the second malloc. In this case, after the second malloc, attackers will be able to own this specific memory. And then attacker can use arbitrary read or arbitrary write to change the information in the victim memory or read the sensitive information from the victim memory. Use after free vulnerability is a sophisticated vulnerability. However, understanding it is not very hard. On the high level, the vulnerabilities happen because when a chunk is freed, the chunk will be reused to store the metadata. This is by design of malloc. But then because of this design, attackers will have the chance to add the malloc if there is a vulnerability of use after free, and then change the metadata, which decides the structure of Tcache. To better demonstrate use after free vulnerability, I'm going to show you a demo. Suppose that we have a program called Gym, and this is an exercising program for us to go over vulnerabilities such as use after free. Inside the Gym program, it has a menu, and users who interact with the Gym will be able to malloc free, added list all the pointers that are related to allocated memory. Now we're going to use GDB. We run gem with debugging. And then we check the runtime layout of the heap. And hopefully this will help us understand how a vulnerability of use after free happen and how that can hurt the execution of the program. Now we run the program again. And this time, we're going to first malloc a new chunk with a size of 8 bytes. As I mentioned in the last video, the minimum of the chunk is 32 bytes. So even though I am allocating 8 bytes, now if we use this to look at the heap, we will find that a new chunk is created with the size of hex 20, which is 32 bytes. Now let's continue. And then next, I'm going to free this chunk. And let's look at the heap again. So this is the chunk that we just freed. And now, if we look at the debugging information, it nicely shows that this chunk right now belongs to Tcache beans. And let's take a look at beans. We could use Tcache bean, or we can just use beans in the pounded back command. So we see that right now, there is one bean that has filled in Tcache beans, and this bean is with the size of hex 20. Each Tcache bean can have at most 7 chunks. In this case, since we have only one chunk freed, the free chunk will be stored in Tcache bean. And as it shows over here, this is the address of the free chunk. So this is hex 603260, which corresponds to the address over here. Now let's continue executing. And I'm going to list the manual again. And next, although the chunk has been freed, we are going to edit it anyway. So we can use the edit command. And then the pointer is with index of 0. And next, what we're going to do is we're going to put some value over here. I'm going to put some random A's over here. And although the chunk is freed, this command will still be able to work. So we just finish executing this editing command. And now let's pause the program and check heap again. So you see that here, we have put the string of a lot of A's, onto the address of hex 603260. And if you look at the beans, you found right now, bean of 603260 has another next one, which is AAAs. And now let's continue. List the manual again. And the next, what I'm going to do is I'm going to malloc again with the same size. And we can do list. We found that this time, the pointer is hex 603260, which is the one that we just freed before. And now let's do another malloc. All right, now we trigger a segmentation fault. And this is because the value that we put into the heap cannot be referenced since this is AAAA. And if you look at this again, you see that those is the information, and glibc will consider this as the next pointer that they want to allocate a chunk to. If we change the value of AAA to something else, say a legitimate pointer, then we will be able to allocate a place with this address that we can control. In order to do that, I wrote a small script. And then for the script, I already include malloc, free, added, exit, 4 different kinds of interaction corresponding to the menu. And then what we're going to do is to change the location of malloc, which is the global offset table got, replace that with a winning function so that when malloc is called again, we will be able to go to the winning function and win the program. And before that, let's quickly go over the source code of Gym. So we see that here there is a winning function. And also there are also utility functions which is corresponding to the menu items such as malloc, free, and added. So for us, our goal is to replace malloc so that it will redirect to function win. In this case, when we use the menu and do malloc again, when function malloc, this is the one that comes from glibc, when function malloc is invoked again, it will actually go to winning function. So now I open attacking script again. And this time I'm gonna remove launch attack and we're gonna write launch attack together. At the beginning of the program, I specify the program name, which is Gym, and then I load it as an ELF object. And later on, I will use this object to locate the symbol, such as the function address of winning function and that of malloc in the global offset table. Function malloc, free, added, and exit maps to the command that interact with the Gym program. And also it corresponds to mallocing with a specific size, which I put 8 over here. You can also change the other size. And free a specific pointer with the index, added a specific location with a specific content, and exit the program. And here I use end of menu just to track where we are at and clean up the buffer, which is the inputs that we receive from program Gym. And then in the main function, I just start running the program depending on if I want to use GDB, and then start to interact with the program. So now let's start to write launch attack together. To take advantage of use after free, we first need to put some free chunk into Tcache. So the first step for us is to put some stuff into Tcache. So we need to malloc and then free so that there is content. And specifically, this is what we call chunk in Tcache. And then the second step is that we want to add the content. So now the next what we need to do is to edit the freed chunk in Tcache bin. The third is to malloc again. And in the first time of malloc, we will get the free chunk. In the second time of malloc, we will get the victim pointer. Finally, once we get the victim pointer, we're going to change the victim pointer's value to the value of winning function. And here, the victim pointer is what we want of the function malloc. So for the fifth step, what we need to do is to change the pointer to, which is the global offset table of malloc, to the function, the address of winning function. And after we prepare everything, then last, what we need to do is just to malloc again. Okay, so now we have a pretty clear steps, and we just need to use our utility function to fulfill those steps. So the first step is to do malloc. So what we need to do is to malloc and then free. And this time, after we malloc, this is going to be the first, so which is the 0 pointer. That's why we put 0 over here. Next, we're going to add the free chunk. So we want to do add it, and then the index of the chunk should be 0, and then we need to put the content. So what content that we want to put? Remember that in this case, we want to put the value of our victim memory, because later on we want to get that particular memory so that we can read and write. So here, the victim pointer is the address of the global offset table of malloc. And this is why we have an elf object, because in this case, if we have the elf object, what we could do is we can use E, and then you can do got with the name of the function. And we need to wrap it with little endian. Little endian is N64-bit, so we use P64 to pack it up. And we put pointer over here. In the third step, we need to malloc again with the same size. And this is going to be the first pointer. And we going to malloc again so that we will be able to get the victim pointer. And this should be the second pointer, which is also the victim pointer. After we get the victim pointer, we need to add it again so that we can overwrite the value on that specific memory place. So we need to do add it, and this is the second pointer, and the value should be the winning function. So we want to wrap it with P64, and then here we could do E dot symbols, and then we can put win over here. Nice. Finally, at this stage, we should be able to call malloc again to get the actual winning function, because right now we already pave all the path and make sure that the address of malloc is right now storing as the address of win. So here we could do is we're going to pretty straightforward to interact with this server. Nice. Now let's run this. Since I'm using Vim, I could do color and then ban, and then /% which represents the name of the current address. But if you are not using them, you can just open another terminal and use whatever way you prefer to run the script. All right, now it has an error, and this is because malloc only takes one argument, because I already hard-coded mallocing 8 over here. So actually, I'm going to change the definition of function malloc. Now let's try again. Another function calling error because of function free. That's because I forgot to pass the process to function free. All right, let's try this again. That is interactive. Good. Now we're switching to the interactive model. We could do list. So it's showing all the information again. And then we'll do malloc 8. Actually, here you can put arbitrary size over there because we don't really care what size it is. When we do malloc, it will call the actual winning function, which doesn't take any argument anyway. So we just put the arbitrary value. And we successfully call function win because we see the message of you win. This demo shows you how to take advantage of use after free to trigger that and control the execution of the program. Now we're going to conclude use after free, and hopefully that this summary will give you a high level and more essential idea for how use after free vulnerability happens and how to use them. So the core idea of use after free vulnerability is that once a memory chunk is freed, metadata will be stored into the chunk. If there is a use after free vulnerability, attacker will be able to use the freed chunk and continue adding the chunk. In this case, when the attacker added the chunk, the attacker is not added the data storing in the chunk, but instead the attacker is editing the metadata of the heap that is stored on the chunk. By manipulating the metadata on the heap, attacker will be able to change the layout of the memory. Furthermore, an attacker can overwrite the content on the chunk so that make this free chunk to link to a victim memory into a bin. And after that, attacker can use malloc or programs that are related to malloc to reallocating memory with the same size so that it will get the access of victim memory by heap allocation. After attacker gets access to the victim memory, attacker can read or write arbitrary information from the victim memory. And this comes with an arbitrary read or write. Once attackers have this capability of arbitrary read or write, attacker can use different ways to achieve arbitrary execution. For example, attacker can overwrite the global offset table so that next time when any function in global offset table is called, it will actually redirect to a malicious function or a malicious flow that contains the command that the attacker inserted. The attacker can also use arbitrary read or write to overwrite the saved return address on stack. Also, it can overwrite a function pointer. It doesn't have to be in global offset table or on stack. Or the attacker use it to overwrite a glibc function, such as __malloc hook. For those malicious actions, arbitrary read helps in the way that it will help attackers to locate the base address of libc. If the binary itself is a position-independent code, then we need to know where the base of function are, so that we'll be able to locate the rest of the function. Therefore, arbitrary read is helpful. It will help us to find the base of libc. For example, if we have arbitrary read and then we use that to find a function pointer, or say, a content from global offset table, we can use that arbitrary read to find the actual address of a libc function. And starting from the libc function, if we know the version of libc, we'll be able to get the base of libc. And also, we can get the location of the other libc functions. Starting from there, we can also use robchain to filtrate the entire execution. But again, even for robchain, we still need to know the base address because usually those rob gadgets coming from a library, and we need to know where the library is loaded so that we can locate those rob gadgets correctly. Finally, starting from arbitrary execution, an attacker can execute malicious code, such as a malicious function, or shellcode, or robchain. All right, this is all what I have for use of the free vulnerabilities on Tcache. I hope that you learned from this video the basic process of use of the free and especially use of the free on Tcache. Particularly, you need to remember that for use of the free on Tcache, you need to put a free chunk into a Tcache and then change the information, added this free chunk so that the chunk will actually, by manipulation, link to another victim. Starting from there, you need to do 2 times of malloc so that the first time you will get the free chunk that you just manipulate, and then for the second time, you will be able to get the victim. Starting from there, you can use this to write or read, do whatever you like, so that you can have an arbitrary read or write, and then from there, you will be able to get an arbitrary execution.